Hello everyone and welcome back to MrMiers Math Channel. Today in Chapter 10, Day 2, we're going to continue where we left off last video. And we're going to talk about the standard deviation and we're going to talk about transformations on data. Alright, so let's get into it. Alright, so one problem with using the range to talk about the distribution in the data set or the spread of the data set is that one, there's only two numbers that we're using, and then two, it doesn't really give us much information. It literally just gives us the span in the data set, and that's it. So if we want something a little bit more useful that uses all of the values of the data set, we might use standard deviation. Right, so the standard deviation of a numerical data set is basically the measure of how much a typical value in the data set differs from the mean. Okay, so to talk about standard deviation, we use the following symbol, sigma. And it's given by this equation. Now we're going to break down this equation into simpler parts so that it's not too intimidating for us. So in this equation, n is the number of data values in the data set. X bar, of course, is the mean, and notice that appears more than once here. We see a lot of adding and we see some squaring. Okay, and then x sub 1, x sub 2, and so on are just the individual data values in the data set. So x sub 1 would be maybe the first data value that we're using, and then x sub 2 is the second data value that we're using. Okay, the deviation of the data value x is the difference between the data value and the mean in the data set. So you can see we're finding the difference, we're squaring that, and then we're adding it to the difference between another data value and the mean, and squaring that, and so on. Okay, so what we're going to do is find the mean, which is x bar, and then in the next step, we're going to find the deviation of each data value. We're going to square it. We're going to find the mean of these squared deviations, which is called the variance, by the way. And then we're going to take the square root of the variance to find the standard deviation. Now, like I said, we're going to break this down, and we're going to use a table to do that, so it's a little bit more neatly designed. So let's get into it with this first example. All right, so once again, we're going to find the standard deviation, and what we're going to do first is display this with a table. So in our table, we have on the left column all of our data values in the data set. Now, this one is already started for us because in the second column, we have our mean. So normally we'd calculate the mean first, and what we're going to do is just write the mean all down that column. Now the next step is to fill in column 3, which is the deviation between a data value and the mean in our data set. So for this data value, to find that deviation, we would just do 20 minus 25, which would be negative 5. All right, 29 minus 25 would be 4. 19 minus 25 would be negative 6. 22 minus 25 would be negative 3. 25 minus 25 would be 0, and so on. So we would get then 2, 2, 4, 5, negative 5, negative 4, and then 6. So we found the deviations between each data in the data set and the mean. Now what we're going to do is square those deviations. So when squaring the deviations, it doesn't matter if that value is negative or if that value is positive. Okay, when we get that value squared, it's always going to be a positive number here. All right, so we don't have to worry about the sign. Let's just square each one of these values. So negative 5 squared is 25, just like 5 squared would be 25. All right, 4 squared is 16, then we'd have 36, 9, 0, 4, 4, 16, 25, 25, 16, and then 36. All right, now we're going to use a little bit of the equation here. In the equation, basically what we have is the square root of the sum of all those deviations, and I'm using this symbol for the sum, divided by n. So what we need to do is find the sum, or the total of that rightmost column. So we're just going to add up all these values. If we do that, we get 212. So now we can find the standard deviation. we're going to take the square root of 212 on the amount of data values, which is 12. All right, so now when we find the square root, we get 4.2. Now this data set was from the previous video, which talked about the show, the competition, the cooking show. All right, so this was show A in that competition, and these data values are the ages. So the standard deviation in this data set is 4.2, which is talking about 4.2 years of age. Just so that this number actually makes some sense, I'm going to add a little aside to this. Now this isn't technically in the chapter, but I think it probably should be. If we were to display that these data values graphically, many of us know about like the bell curve, whether we're talking about grades in a class or something else. If the data set is what's called normally distributed, then it's going to follow a bell curve. Now this bell curve is a little off, so let me redo that. And oh man, my graphing skills, I'll tell you what. All right, that's a little bit better. So if a data set is normally distributed, oftentimes we would see that the mean would be about right here, okay? And then the standard deviation is going to be, you know, how far most of the values are from that mean. So I'm going to draw two other things here. And so that this number makes sense, typically within one standard deviation of the mean lies 68% of the population. All right, between here and here would be 68% of the population within one standard deviation of the mean. Within two standard deviations of the mean, so I'm just going to write minus 2 plus 2, right here would be 95, about 95% of the data set. And then finally, within 3 standard deviations of the mean should lie about 99% of the data set. All right, so this is a different way to describe what's normal in a data set. So although this mainly is used when we're dealing with many more data values, for this show, to make sense of this value, 68% of the people on this show lie within one standard deviation of the mean. The mean is 25 years, okay, so if we go one standard deviation less than the mean, so subtract 4.2 from the mean, we would get about 21. I'm just going to use integers here. And then if we go one standard deviation beyond the mean, we'd get about 29. So basically what this is saying is 68% of the population is between 21 and 29 on this show. All right, then 95% of the population is within two standard deviations, and 99% of the population should be within 3 standard deviations. Now this isn't a hard and fast rule, but it's an approximation about where the data set is, or where these people lie, or the data values lie in the data set. All right, so hopefully that gives you some context as to what we're talking about when we talk about the standard deviation. All right, let's move on. All right, now given this data set, let's find the new a different standard deviation. So the first thing that we would do is list the data values in the left-hand column. That's already done for us. The next thing that we would want to do is find the average or the mean. So x bar in this case, if we calculate it, would be 32. So we're going to write 32 in that second column for the mean. Now in the third column, what we're going to do is find the difference between each one of these data values and the mean in this data set. So 35 minus 32 would be 3, then we have 0, then we have -7, negative 13, negative 11, 8, 20, 3, negative 3, negative 12, 11, and 1. Now, of course, in the right-hand column, what we're going to do is square these values from that third column. So we're going to square 3, and we get 9, and then 0, 49, 169, 121, 64, 400, 9, 9, 144, 121, and 1. And then, like before, we're going to find the total of that rightmost column. Now, if we add up all these values, we get 1,096. And then to find the standard deviation, we're going to take the square root of the sum of those squared deviations, which is 1,096, divided by the number of data values that we have in this data set, and that's 12, because we're still talking about the show here. Now, when we take the square root of that quantity, we get about 9.6. So in this show, based on this data set, using that 68, 95, 99 rule, 68% of the population should be within about 10 years of the average of the person with the average age. Okay. Now, if we look at this for small sample sizes, this is not going to work. Okay, this is not going to be very accurate. But in a really, really big sample size that's normally distributed, this is going to be pretty accurate. Alrighty, let's move on now. Now we're going to talk about data transformation. So data transformation is a procedure that uses just a mathematical operation to change a data set into a different data set. We could see this all the time if you're some nerd like me using Excel all the time. If we just want to do one thing to a data set, we could transform that data using a simple mathematical operation. So let's first talk about data transformations using addition. When a real number k is added to each value in a numerical data set, the measures of center of the new data set can just be found by adding k to the original measures of center. So pretty simple, right? If we had to add some number to all the data values, we just add that number to all the measures of center. However, we wouldn't add that measure or add that number to all the measures of variation. Okay, the measures of variation would still be the same, right? If we had some data set, okay, right here, and we added, k units, right, so that it then gets transformed over here, right? The range, if we add k to each one of these data values, is still going to be the same. All right, so the measures of variation don't change. The measures of center do change. All right, if we're talking about data transformations using multiplication, however, that does change. Okay, so when each value in a numerical data set is multiplied by a real number k, where k is greater than 0, the measure of center and variation can be found by multiplying the original measures by k. So if you want to transform data using multiplication, it's pretty simple. It works all across the board for measures of center and for measures of variation. So that's nice to know. All right, so let's take a look at example 5. Okay, so that we don't have to go through the whole process again, here was the information that we received from that very first example in Chapter 10, Day 1. All right, so here's the students' hourly wages, and let's say now everyone's hourly wage increases by 50 cents. They get a 50-cent raise. We want to see what effect that has on the mean, median, mode, range, and standard deviation. Now, adding just some real number k doesn't affect the range and standard deviation, so these would still be the same. But now these measures of center here would be different. So if we added 50 cents to the original mean, we'd get 10.15, and that would be our new mean. All right, if we added 50 cents to the median, we'd get $9.20. If we added 50 cents to the mode, we'd get $8.75. So that would change these measures of center there. Now, last one, we're going to talk about multiplication here. Let's say instead of just a flat 50-cent raise, they got a raise based on a percentage. So each hourly wage increased by 10%. So they all got a 10% raise. Now that affects everything. So it affects all measures of center and the measures of variation. So essentially, what we've got to do is just multiply each one of these by 1.1. All right, increase by 10% means multiply by 1.1. If we multiply it by 1, it stays the same. And then if we increase it, we would have to add that to 1. And 10% would be 0.1. So we're multiplying everything across the board by 1.1. So now that gives us some new measures of center and variation. All right, so the new mean, if we multiply everything by 1.1, would be $10.62. The median would be $9.57. The mode would be $9.08. The range would be $9.08. And then the standard deviation would then be $2.87. Awesome sauce. I hope you enjoyed this. I hope you found this helpful in some way. If you did, like, share, subscribe, and thank you and have a good day.